Hi guys, good afternoon for everyone, and I'm very glad to be here. It's my third moment. I prepared something to present this in the Avenue Code, so I'm very happy to participate in this Tech Week. And for this presentation, I choose to talk about the Duckdb. The pronunciation is correct, right? So there's a very nice tool become more famous in a few days ago in the LinkedIn, specifically in the Brazil. Okay, but this tool is not very newest. This tool exists some time ago, but in the last updates, the DuckDB have more evidence because we can start to see some interesting statistics related with the data processing using this tool. In the last year, I prepared some machine learning in the Avenue Code related with another data processing tool. It's a polars, right? Like a library in the Python to use instead of the pandas, for example. And now we have another tool like DuckDB, but this tool it's a little bit different because we don't have like the not only the process part but the store part too. But before to start to talk about the DuckDB, I just introduce myself. Okay, so I'm Yuri Rosal. I'm senior data engineer in the Avenue Code. I have like 1 year of the working in the Avenue Code. So I'm very happy, and I like to learn new things and teach the things to another people. I love to help everyone. I think we can um, increase a lot in the process to share knowledge and experiences in general. Um, and yeah, about the personal part, I love video games and cocktails. And sometimes I have like a bartender in the some friends, uh, and I like to travel to other places in the Brazil. Yeah, I'm Brazilian guy, so I love to travel in the Brazil and to other countries too. And I practice jiu-jitsu, and I like to create techno content in social media. So sorry about my my Alexa. And yeah, that is a little bit about me. So for this moment, I prepared this timeline. So initially, I talk about the motivation, what kind of things to justify the existence related with the DuckDB, because we have a lot other data tools, right? The pandas, the polars. We have this SQL alchemy to store the data and SQLite to store the data too. So why the DuckDB exists? What's the kind of thing the DuckDB justify to exist to try to solve the problem related with the data tools exists in all days. So this is the kind of thing I talk about it in the topic one. After that, I have I prepare like overview related with the tool and the main features. And after that, we have a hands-on just to show to you how to interact and work with the DuckDB. And in the end of the slide, I put the references I use it to prepare the things and the data I usage. Okay, so yeah, so related with the motivation, there are the relational databases. I think is uh, the oldest technology related with the stored data, right? So yeah, it's more traditional, and we have like a lot of years of support related with this technology. So a lot of community documentation and projects in university and companies related with the relational databases. So it's very traditional and very consistent tool related with the engineering in general. But we have some problems related with the work in the some relational databases. For example, the time consuming configuration can be very complex to configure and to have a good result related. And nowadays we have like a cloud computing technologies to help with this, but in general, it's very challenging to have a good time consuming configuration to fit with the performance and the things the company we wants in the when we think the time to consume the data, the time and the costs related to write and read the data, so the throughputs. We need to care with a lot of things related with the infrastructure in that case. Another point is we don't have integration with analytical system like in an easy way, right? We need to use another other tools to help us with the process to integrate the databases with the like another kind of data storages or the computing pieces to go to read the data and process the data. So yeah, it's not very easy to integrate the things related with that, and high transfer costs. If we need to, for example, migrate the databases for for example, between the clouds or the another technologies or infrastructure, we have more complexity to do this task using minimal costs. So yeah, this is another problem related with that. Um, Data frames is a data tool we use, for example, in the Python. So we need to read some data in the database and processing the things, transform, work with the data type and data formats inside of each column in this database. So we have some complexity to interact with that. We want to do this in a, like inside of a computing entity, not inside in the database, because in some cases we can just use the SQL to run the things, that run the queries and process some data. But sometimes when we think about the automation of this process, like a big data pipelines or in more complex data pipelines, we probably involve the computing tasks outside of the database. So in that case, the data frames can help us to represent the data and to transform the things and manipulate the data in general. So pandas, polars is more famous when we talk about the Python. So it's very easy to use and to set up. You can interact with the relational API and run the SQL queries inside of this tool. So yeah, we can easily use this to manipulate the data. And a good feature in the data frames is the automatic schema detection. Because in the database, when we work in relational database, it's very common to define the schema initially. But in the case of pandas and polars, for example, we have a good process to automatically detect the schema of the table and like to connect the data types related with the database and the data types inside of the Python, for example. So this kind of thing is very abstract to us. But we have problems. So we have a limitation on queries because the SQL DLT is very limited. So we can run some queries and do some things, specific things, but it's not very, how can I say, huge of possibilities and to work with SQL inside of the data frames in pandas or polars, for example. So it's very restrictable, okay? We don't have the query optimization. The work with memory is very limited. I think it's very common. Think about the person work with like a data engineer or data scientist. Sometimes we trying to read some CSV or Excel file with a huge number of records, for example, 1 million or more lines in this file. And when we try to read this in the the pandas inside of Python code, for example, we have some problem related with the memory. For example, it's very common. And we can think about the parallelism to work and try to avoid the problems related with the memory, but the parallelism it's limited too. So yeah, we don't have a lot flexibility to work with a huge files, for example, or a huge number of records to help us to manage the memory and the processing in general. So this is a problem related to data frames, and we have the SQLite. SQLite is a most used database in the world. It's very good because this kind of tool we can use like an embedded database, so the server is not needed. We just store everything, the tables and the records inside of a single file. So it's very good. It's a public domain. It's another good thing. And it's a technology integrated with multiple languages. And it's very easy to use and to set up. And the SQLite is very used like a reference to the people developed the Duckdb. If you know about the SQLite, you see a lot of things common between these technologies, okay? But yeah, we have a problems too in the SQLite. First, it's very user restriction related. We don't have like a possibility to manage the permissions between the different people or something like that. We have very restricted related with the kind of management, okay? When we need to store big data, for example, we can be problems related with the SQLite, and we just store the data. The SQLite don't have the possibility to processing the things. We don't have an engine inside of SQLite. The focus of the SQLite is just to store the data. So the idea of the Duckdb is just to try to solve all the problems related with the relational databases, related with the data frames, and the SQLite. So what is the Duckdb? So the Duckdb is a modern embedded online analytical processing database. So it's possible to store the data in a local file in a single file, the same way in the SQLite, but we have this plus the capacity of the processing and manipulate the data. So the Duckdb more or less connect the idea of the SQLite with the idea of the data frames. So you can easily read some data, store in a single file, and interact with the data, always using the Duckdb. So you have an engine and the capability to process the data. It's possible to run locally. It's very nice. One of the other reasons to Duckdb become more famous in the few days ago, it's because the Duckdb helped a lot to process like a huge CSV files, huge Excel files in the local machine. We in some cases we have a best performance using Duckdb in compared the pandas, polars, and other data tools. And we can use the Duckdb inside of the cloud. We have the modern Duck is like the tool of the same people who are responsible to develop it, the Duckdb, but related with the cloud, okay? And we have the integration with Amazon Web Services and Google Cloud Platform, so you can use the Duckdb in some way inside of the cloud computing. So it's very nice too. It's very rich in the SQLite dialect and optimization in general. A single file, I mentioned about it. It's the same way in the SQLite, okay? And the good part is the integration with other tools and modules in the data science and engineering ecosystem. So in the Python, for example, the Duckdb, we can interact the Duckdb with the polars and with pandas, NumPy, Arrow, like Apache Arrow is another tool to Duckdb can interact very easily. So you can, for example, start to use the Duckdb, and if you need transport the data frame in the Duckdb to the polars or in the pandas, and in the another way you have, like, for example, pandas data frame, and you can use this in the duckdb. So it's very integrated, so very nice. And what's the duckdb what's make the duckdb more fast in compare the pandas and polars, for example? The first thing is the columnar data storage logic is the same feature we have in polars and pandas, because SQLite using the logic to store the row. So if you want to uh, filter some column or filter some record, you need to read the all rows and after that apply the filter, for example. So in that kind of thing, this kind of data storage organization, we always need to read everything. So it's a problem if you have a huge database, for example. In the columnar data storage strategy, we just have the columns like a reference. So if you want to work with a specific columns, it's more easy because we just read the data related with the columns, not the in the rows logic. So it's very different. In that case, it's more easy to fetch the individual columns. It's more easily to have a computational performance um, with a good results, because it's not always needed to read everything. So it's more easy to select the columns, and it's more easy to you to do immersive savings on disk, IO, using memory. So it's more performatic. Okay. For example, suppose we have a 1 terabyte table with like 100 columns, okay? And we need just select 5 columns. In the row store strategy, we need to read everything. So read the entire 1 terabyte data from the disk. And suppose the disk have this processing capacity like the 100 megabytes per second. So in that case, we need to store to reserve like 3 hours to process these columns in the raw store database, for example. But in the column store, it's different because we just read the 5 columns directly. So, for example, instead of to read everything like the whole table, we just read the data related to the 5 columns in suppose like uh, 50 gigabytes. So using this kind of the same capacity of the disk, we just have 1 minute to process this. So we have more benefits to work in the column store in that case. The another feature is very interesting is the data compression. I don't deep a lot related with that because it's very specific, but the DuckDB use different techniques to data comprehension. So I put in the slide some algorithms related with this kind of thing. So we have, for example, bit packing, dictionary for, and another tools. And this kind of techniques is used in the case, for example, when we have the data duplication, the floating point number, the time series like related with the data, sequential data, for example. So it's very a deep technical thing, but this techniques helps to save the space of memory and space of storage using the data comprehension. In some tests, you can see this the statisticals in the Duckdb documentation, you can save 3 or 5 times on storages. For example, if you have, I put the example here. So if you have, in the same example I present in the last slide, in the same task to read the 5 columns with the 50 gigabytes, we have 8 minutes. Suppose the situation we don't have a comprehension data, okay? But if you have a comprehension data and using the column store, in that case, we reduce the processing, like the complexity, the space of the storage in 5 times. So instead of have like a 50 gigabytes, we just have the 10 gigabytes, for example. And in that case, we just have 1 minute and 40 seconds to read everything. So yeah, it's a very difference here. And yeah, this is some feature that DuckDB use. And the last feature I talk about it, I want to just clarify there are a lot of features and strategies that DuckDB use to have a good performance and strategies to have a good processing and they work with a huge files. But I select just 3 because to the time box of this presentation. But in the documentation of the DuckDB, we have a lot of papers responsible to the people develop the DuckDB and talk about in more detail related with these features and the other features I don't mention. Uh, uh, I won't mention in this presentation. So if you have curiosity, I'm suggest you to check the documentation, the papers is very nice, okay? But yeah, related with the last feature, vectorized processing. This is very good because what's the idea? In the slide, I put an image related to a representation of the processor. So the processor core, we have some parts divided related with the cache. This part of the cache, for example, the L1 and the L2 caches, is a part of the processor. Like think about the CPU, the part of the CPU. It's more faster to process the things and do the things in compare the other parts. For example, the L3 cache, because the L3 cache is like shared with another process things, and you have the other parts of the processor share with the other process in your machine. So it's more it's more easy to have problems related with the lazy of the processing in that case. But what's the DuckDB do to help the process? When we try to query some table, the DuckDB split the processing in a little parts to try to fit each part of this process inside of L1 cache and L2 cache, because in that case it's more easy to have a fastest processing. So in that case, DuckDB always try to use this part of your processor, like the cache, because it's more fastest and compare the others. So we have some gain of the productivity and the performance use this. So the DuckDB separate the tasks to work everything in the cache logic, and after that union everything and becomes to you the result. So it's very nice. It's very smart strategy related with this, because we have the columnar strategy to storage plus the data comprehension and plus the vectorized processing related with the columns. So it's very good. But yeah, this is the main features just related with the architecture and engineering related with the DuckDB. But I think it's a good question. Why DuckDB? Why Duck? What's the explanation related with this name? The cooperative response is because the duck is a versatile animal, like the duck walks, swims, flies, and like the duck normally living in a data lake, like in lake, right? Just to connect with the data logic. But this is the cooperative response, okay? And in some presentation, did for some person responsible to the developer of the Duckdb, we have the correct and the real response of this question is because the one of responsibles to the team to develop this tool living in a boat. So this person have a duck. So this is the explanation. It's just this. It's like just a representation of this person, like it's not very explanation related with the data or something, right? With that, it's very simple, the response in general. And yeah, let's to the hands-on. I prepare very simple, just to show to us, to you, the things and how to use the Duckdb. So in my machine, I have some scripts, okay? And here we have the Duckdb. This is a file. If you access the official site of the website of the Duckdb, you can just download this file and you just use this file to run the Duckdb. So for example, in my machine, I open my terminal, so I in the same path, and I just calls the duckdb in this way. And if you see, I use this version, okay, of the duckdb, and we have a observation here related, because when I run the duckdb, not specifically the file of the database, we just work in the memory databases. So if I create some data here or process something, but not persist in a single file of the database, for example, if I did this and close this terminal, for example, I lost the things. So it's very nice normally to use a single file or persist the data in some way. Because if you don't, you lost the things in general. So I pick some database. I use this SQLite sample database. You can download this. It's very simple, and you just download the single file, because it's like a SQLite example, right? So I put this file here in this folder. So I just calls this file. So for example, open. Let me pick the name of the folder. Just a second. Name of the folder, and sicknook.db. Don't needed this. And yeah, I just open this database so I can use, for example, show tables. Let me see. Uh, I it's not needed. This is the correct name. Chinook. Yeah, this is right. I think now I can see the tables. Yeah, that's right. So all the tables in here, and we have some records. So for example, here we can work in the same way in like in the SQL, like in a console of the some relational databases, the same thing. So for example, I can select from albums. You see, I can select and make carry here. And the visualization, sorry. Sorry for the Alexa again.
It's fine.
Pare. This intelligent, artificial intelligence is very crazy. But okay, continue. So the visualization of the data is very nice. If you see, I can see the data very easy, and the data type of each column and the number of the rows here and the columns, right? So very nice. But I don't write just the SQL, because I think this idea of the presentation shows the things, the special things related to the DuckDB. So the people in the Duckdb work with some features to increase the functionality related with the SQLite dialect. So, for example, if you want just to select everything, involves everything, the whole table in some query, instead of to use this, for example, we can just write from invoices. So if I run this, it's working the same way. So it's very detailed, but you write less to just to select the table or involves the all the table. Other points, we can, for example, use some functions. So we have the summarize clause. So if I use the summarize and select some table, for example, invoices, we can see a very review of the table. So in this operation, we can see all the columns, and for each column, we have the data type, for example, the mean, max value, the some statistical things like the quartiles, the median, the mean, the count, the null percentage. So it's very similar with the describe we have in pandas and polars, very usage for by the data scientists in general. So we can do this inside of that to have some insights and details related with some table. So it's very good. We have the possibility, other thing it's we have in the DuckDB. For example, let me just pick the invoices again. Invoices, I put some limits just to have more visual. Great. For example, if you want to select all the tables, instead of, we want to select the majority of the columns, right? But we don't need the custom ID column, for example. So in that case, you just can write select and write the each column. But yeah, we have more columns we want to select and compare the columns we don't want to select. So in that case, we can use the exclude function. So I can write, for example, select, exclude, and here I can just write the columns I don't want to include in this query. So in this case, for example, customer ID. And we can specify the table, invoices. In that case, I put the limit just to, and if you see, I have the same result, but we don't have the custom ID because I exclude this of my selection. So it's more practical to do this. A good thing is because we don't have in the select tool, we have the possibility to use some regex process like the regular expressions, okay? So we can use the columns functions, for example. So let's imagine I want to select just the billing columns, like the columns we have the billing in the name, like the billing address, billing city. So in that case, we can use the columns and put here billing dot star. So if I run this from invoices limit 2, I just have the columns, we have a billing. So you can apply the regex here. So it's very nice because it's more easily to specify the columns you want. And it's not needed to literally write the name of the columns. So it's very practical. And we have the describe too. It's like another way to extract some details related with some table. So I can use the describe from invoices. Sorry, describe here. In that case, it's more, we don't have like the statistical details in the summarize. In that case, we just see the column type, if we can have null values, if this column mark like a primary key, for example, or foreign key, it's possible in the Duckdb, we can see in this column. If you have the default value, you can see this. And if you have extra information, we can see in this column. So it's very a review of the schema of the table in that case, okay? So this is a very fast detail related to work in the console, using the Duckdb. In the documentation, we have a lot of things. We can use, for example, the group by wall to, for example, let me just show this. If I want, for example, uh, group the Billy count, Billy country, sorry, and Billy state, sum the things in the voices, because in this table we have the invoices information, right? In the total, we can see the value of each invoice. So if you want to group by the billing city and billing state, sum the total, we can do this using this, for example, select billing city, billing state. I think it's better first the billing state and after the billing city. And we can just put the sum total from invoices limit 5. So if I do this and use the group by all, let's run and see the output. So what happened here? In that case, the group by all, the DuckDB understand, okay, you want to group by using the columns you just select. So the DuckDB understand this when we use the group by all. It's more easy to write this. And you can write less in compared to put in the hard coded, again, the name of the columns you want to group by. If in that case you have the same columns here, you just can use the group by all. So we have this kind of feature and another details related with the union operation and the pivot operation, but it's very more specific, so I don't put in this presentation, okay? But the documentation of the DuckDB is very nice, so you can check and see more details, okay? But another thing I want to show to you here is just the Python code, right? Just to relate it with the thing. So in my Visual Studio Code, I just have the Python script here just to check how this works in the Python, okay? So for example, let's focus in the first line, okay? Here, just uncomment this line. So for example, if we want to use the DuckDB in the Python, we just need to install the library using the pip, like pip install DuckDB, and we can use in the Python code. So the DuckDB, we have the process to connect with the some database, and we can read the files too. I will show to us in the console. But yeah, it's the same way. We can just use the DuckDB, for example, .sql, and run a queries here. So for example, I can run the same queries in the console. I can run inside of my Python code and have the result in the console of the Python. I can store the things in some data types, data structures here. So for example, if I put in the end of my instruction, like fetch all, we have the results stored in a Python object, like a list of tuples, okay? We can store the result in a data frame, in the pandas data frame, for example, in polars data frame, in arrow table related with the arrow library in the Python, and we can have this in the NumPy arrays. So I can store the things in some data structure to persist in some way in the logic of the code, right? And we can connect the DuckDB in a single file and store the things in some table. I'll show this. But yeah, just to show to you, the usage in the Python is very simple. But related with the files, okay? So I download this data set in the Kaggle, like the big sales data is very CSV files. So I store some these CSV files in this folder in the data. So we have, for example, the sales CSV. So let's suppose I want to read this file using the DuckDB. How to do this? We just can copy the path. So I just copy this. And in the console, for example, I can do this. Select from. I can just use the read CSV function, for example, here, and put the path. So sales.csv. I use this and run. Let me see. I run, everything wrongs. See. Sales. I think that's the problem. Let me see if yeah, just the slash. I use the wrong slash. So yeah, if you see, I run the CSV inside to my DuckDB console. So in that case, I can work here using the SQL process. So I can using a query and related with the some file, and we have the read CSV function. We have the read Parquet function to work with Parquet files. So yeah, we can work it with a different format of the files, and it's very nice. And we can write the results in some file. So for example, right, we can, let's see an example. I can create a table inside of my database. So create table, for example, sales. And I want to store in this table my sales. So in that case, I just run the s select from. And I can use the read CSV, right? But I can just write the path here. Don't using the read CSV function. The benefit of use the read CSV function is just like a syntax option, okay? And you can pass some parameters. So for example, in the CSV file, depends of the file, we have like a different chart to separate the things, the columns, and define the what kind of data pertains of each column. And normally, the default is just use this kind of character, but sometimes we can have a slash or a vertical thing. I don't remember the correct name of this chart. Okay, but yeah, if you want to specify the kind of delimiter of the columns in the CSV, we can pass this by a parameter inside of the read CSV, right? But yeah, just copy again my path. Let me just to change this and sales.csv. So if I run this and use the show tables again, I can see I have sales here. So now I have the same data in my CSV inside of my database single file. So if I run select from sales limit to, I can see the same result, right? So it's very nice. And if I want to export some data to some file. So for example, imagine we want just to pick the sales related with the Samsung, okay? So in that case, I can select from sales, where brands like Samsung. In that case, we just have the sales related with the Samsung brand, okay? And I want to store the result in some CSV file. So in that case, we just can do this. Copy. So I will copy the result of the query to sales Samsung CSV, for example. I use the with just to add some parameters in that case. So we have a header true in that case, and we can use the delimiter like using this default. If I run this and see my path when I run in the Duckdb, I can see sales Samsung file. So let's just select this to see. Oh, sales Samsung.csv. If I can see the same CSV, but just with the Samsung. So I export my results to a CSV file if you want. But I have the same table initially I created in this database too. So I persist the things in the files and in the data in general, right? The last thing I want to show this presentation, it's very fast. It's just related with the Google Cloud, how to connect with the Google Cloud. So for do that, it's the same way we can connect in the Amazon Web Services. Is the same thing. Okay, so for example, here I have some cloud storage, and in this cloud storage, I have the CSV files related with the sales. So if you connect with the cloud storage, you can do the same thing I did in my local machine, but the file is inside of the cloud storage, not in your local machine. So it's very nice because it's very easy to do this. First, to do this, we need to access the settings in the cloud storage, this process this part related with the interoperability. I think I pronounced it correctly, all right? And in this part, service account, we need to create some service accounts. In review, you just create some service account to become, to use this like a intermediate between the Duckdb and the cloud storage. You need this to Duckdb can have access of your cloud storage. So we just create this, and here we cite this access key related with that, right? So I will connect with this. Remember, this is a sensitive information, right? Because if someone have this information and use in a bad way, you can have a problems in your cloud storage. So in a real project for a client, it's a good to store the access key in like environment variables or in using the secret manager of the Google Cloud to access these things. But I just use the hard code here in like to demonstrate the connection, right? But it's not a recommendation. So to connect, I will just copy the code because I don't memorize it. So for example, I can just use this create secret if not exists. So I just create a secret related with the Duckdb, right? So copy here. I just replace my secret and my key here. Second, and my secret. Let's run. Okay, connect, success. The if not exists is necessary because I made some tests using the cloud functions in the Google. And the secret, when we run, we can store in memory of the machine. So in some case, if you run the same thing in the same cloud function, for example, a lot of times in sequential way, we can have a problem if you try to create the secret and the secret continues exist in the memory of the machine, because it's very abstract to us, right? So I recommend you use in your script the if not exist part, just to have certain related, if not a problem, to try to create the secret, and this secret exists in the memory yet. So we just use this clausula, this condition, to avoid the kind of problem, okay? So with this connection made, I can, for example, select, let me just pick some buckets, some file here. So in the role, for example, we can pick this and access the Jesu to URI, is like the path in the Google, in the cloud storage, to access this file. So for example, I can do this. We have the data. So it's very fast. I just run locally my machine and collect the data in the CSV inside of cloud storage in the Google Cloud. So it's very nice. In this, it's the same thing, the Amazon Web Services. The only difference is because we put another kind of type here, but the process is very similar to connect and collect the data in the CSV, for example, in the S3 buckets, for example. I don't test in the another things, for example, in the Azure, for example, but I read some articles and I see some people made a connection with another tools, using some trick related to connection. And this kind of thing, it's like you just create a secret in S3 using the credentials of the service you want. And in that case, the Duckdb depends of the technology. We can connect using the S3 logic just to collect the data in another things. I tested using the MinIO. The MinIO is just show to you. MinIO. MinIO is just a tool, right, to storage the objects. Is very similar with the cloud storage in S3. So I don't have here in this machine, but I tested. I put MinIO in some Docker and connect with the Duckdb in another container in the Docker. So it's work too. So in some tools different of Google Cloud and Amazon Web Services, you can try to connect in the Duckdb using the S3 logic of the connection, right? So yeah, that's it in general. It's very, we don't have like a 10 minutes of the presentation related with the hands-on part. So I try to put a general vision and an overview of the idea of the Duckdb and the usage and the main features. So if you have some doubt, I like to answer about it. And yeah, that's it in general. Thanks for the attention.